everybody, so today we're dealing with Trigonometry chapter 22, exercise 22E, question number 24. So this question states that an observer notices an airplane flying directly overhead. 2 minutes later, so this is after 2 minutes, the position of airplane, the angle of elevation from the airplane is 27 degrees. Now after another 2 minutes, if the airplane is traveling with a constant speed and altitude, so this is after another 2 minutes, what is the angle of elevation? So this theta angle is what we have to calculate. So firstly, what is angle of elevation? Angle of elevation is, if this is the point A and this is point B, then the angle of elevation is this point theta. So here this is the initial position of the plane, this is the observer. So when it moves first 2 minutes, it travels a distance of x, and when it moves another 2 minutes, it travels a distance of x, because if speed is equal to distance upon time and speed is constant, time is constant, then distance is also constant. So it would if we are considering that the airplane travels a distance x in the first 2 minutes, it would also travel a distance of x in the next 2 minutes. So the angle of elevation from the first position is 27 degrees, and the angle of elevation from the second position is what we have said is theta. Now, if this is 90 degree, this is 90 degree because they have said that notices a plane directly overhead. So that means it's like all the way 90 degree from the ground. So if this is 90 degree and this is 27, then this is equal to 63. So we'll write here as this angle is equal to 63 degrees. Now we will get started for calculating theta. So firstly, we'll look at the triangle in triangle OSA. Also, if you notice that this is actually a right angle triangle because they're saying that it is traveling with a constant altitude. So in triangle OSA, angle OSA is a right angle. Now once we know this, we can kind of like use trigonometry. So we can write here SOHCAHTOA so that we don't mess anything up. So in this triangle, if this is the angle of this is the theta angle, then this is the opposite, and we have the thing that is equal in this triangle and this triangle is this angle. So we're looking at opposite and adjacent, so we will use tan. So we're gonna say tan 63 degree is equal to opposite, that is SA, upon adjacent, that is SO. That would give us x upon SO. Now we're gonna look at in triangle SBO, angle OSB is a right angle. Now once we know that, we can apply trigonometry in this triangle too, and we can say that tan this angle, so I don't know if you know this triangle, this angle, okay, let's name this angle alpha. So tan alpha is equal to, so tan alpha is equal to opposite upon adjacent. Opposite is SB, adjacent is SO. SB is equal to SA plus AB upon SO, that is 2x upon SO. So now if you look at this equation, let's name this equation 1 and let's name this equation 2. So if you look at this equation, SO is common and x is common in both of these equations. So tan 63 degrees is equal to x upon SO, and tan alpha is equal to 2x upon XO. So we know that x upon SO is equal to tan 63 degree. So we can pull the value of x upon SO in this equation. So we can write from equation 1 and 2, tan alpha is equal to 2 into x upon SO, that is tan 63 degrees. And once we know that, we can say that tan alpha is equal to tan 63 is 1.96. That would mean 1.96 into 2, that would give us 3.93. And then when we calculate alpha from this, we will get alpha as 75.71. And when we get this, we know the value of alpha. Now if you look closely in this angle plus this angle will make this whole 90-degree angle. So we can say from here alpha plus theta is equal to 90 degree, because it's a right angle, because from the ground it's directly overhead. So we can say if alpha is equal to 75.71 plus theta is equal to 90, and from here we can say that theta is equal to 14.3 degrees, and that's the answer. So we can say answer, and then we can say approximately equal to, because a lot of roots, so we can say answer is approximately equal to 14.3 degrees. Thank you.